Okay, so we have done our two-way ANOVA looking at average cholesterol level versus body frame and gender. So can we actually combine more than that? So can we actually things that combine body frame, gender, and location? Because all these are categorical data. So we have 3 body frames, small, medium, large, 2 genders, male and females, and 2 locations, Buckingham and Louisa. What we are trying to do is we are trying to construct 3 null hypotheses now. So our null hypothesis, 1, will be the same as our average cholesterol between small, medium, and large body frame. Okay. The null hypothesis 2 is between males and females. Oops. That's what we did in our two-way ANOVA. Can we expand it? Since if we can expand it to 3 ways, we can expand it to multiple ways, but our data only give us up to 3 ways. So that's the average cholesterol level. Just repeat this, you're going to type it. For people living in Louisa and Buckingham. Buckingham. Let me see, Buckingham. Wait for me. Oops. This is our 3 hypotheses. Okay, we can do that at the same time. So similarly, there's additive model and there's a multiplicative model. Multiplicative model looks at interaction. Okay, additive model looks at one at a time. Okay, so we can use the additive model again. So let's start with additive model first. Cholesterol versus body frame, gender, and we want to add another component called location. Okay, since location is the one that is yeah. All right. So let's see what it gives us. Okay. So you look at it, it only tells us that in terms of the average cholesterol level from between patients living in Louisa and those living in Buckingham, there is no significant difference. The p-value is 0.188. So similar, only body frame is a difference. Okay, you can do the Tukey's HSD, it gives you the same result. Okay, so Tukey's HSD for model. So Tukey's HSD is an easy way for us to compare between all the different samples. Okay, especially if you have, let's say, more than 5, it can be very difficult to do by t-test. You can have to do everything by yourself. So again, Louisa and Buckingham, there's no difference. Okay. So we can actually do the same for our multiplicative model. So multiplicative model, it means that we are looking for possible interaction. So maybe there is a difference between small body frame in Louisa versus medium body frame in Buckingham. Okay, or small body frame of females in Louisa versus large body frame of females in Buckingham. So all these are interacting effects. We want to see how multiple variables work together. So that is where we have multiplicative model, and that gives us something more interesting. So summary of the model. Okay. So see, now we have the 3 additive model. Okay, so for 3 additive model, it only tells us body frame is significantly different. Then we also look at the relationship between the interaction effects between body frame and gender. We also look at the interaction effects between body frame and location. Then body frame, gender and location. So there is no significant difference between the body frame and gender, or body frame and location, or gender and location. Then the third one is body frame, gender, and location. Okay, so there's no significant differences. So it seems that only body frame is the one that is important. Okay, so let's look at our 2K HSD as well. Yes, so it generates a lot of different values. Okay, because it gives us every single comparison. So remember, we have 3 body frame, 2 gender, 2 location. So 3 times 2 will be 6. 6 times 2 will be 12. So it gives us 12 different location, 12 different comparisons. So there's a lot of data for you to look at. Okay. So if you can do 3-way ANOVA, you can go and expand to do 4, 5, 6. It doesn't matter. The steps remains the same. Okay, so that's actually the end of ANOVA here. We'll talk about more interesting what happens if we have ANOVA versus, for example, categorical and non-categorical data. Okay, so we'll come to that in the later installments. Okay, so that's all for today. Bye bye.